the second part of this is what we're going to talk about is upper and lower sums. We broke that in that last example. We broke down that curved area, that curved object, into 5 separate rectangles. Found the area of those rectangles and estimated the area underneath that curve using those rectangles. We looked both on the left side of endpoints and the right side of the endpoints, where it was bigger than the actual area and smaller than the actual area. All right. We're going to talk a little bit more about that, except for we're going to break down those curved objects into more than just more than just 5 rectangles. In fact, we're gonna generalize it and make it and break it down so it's any number of rectangles we want. Because if we found out actually, and I didn't show you, I didn't talk about it in the last video, but what we found out is if we continue to break those triangles into smaller and smaller rectangles, we're gonna get a more accurate reading of what the area is, because our error isn't so much. So if we want to find the upper and lower sum, we're going to generalize it, and it's the same process. All right, to approximate the area of the region, we're going to subdivide it into n intervals. So that's what we did when we went 0. We went 2 minus 0 divided by 5, and we got 2/5. So this time we're just going to go our endpoints divided by n, because we don't know what we're breaking into. We're just going to leave it as n. All right. What we did earlier when we had when we started the last video, the first one, when we used the right endpoints, was an inscribed rectangle. Endpoints will be inside of the curve. And then the second example on the left endpoints is a circumscribed rectangle, the endpoints that are on the outside of the curve. All right. So here's an example to show you of us breaking it into n intervals instead of just any interval that we want, or any number of rectangles that we want. All right. So it says find the upper and lower sums of the region bounded by the graph of f of x equal to x squared and the x-axis between 0 and 2. All right. So we're trying to find the area. Let's graph this for a second here. Here would be a parabola, x squared graph, right? What we're trying to find is the area underneath this curve like this, all right, from 0 all the way to 2, all right? And we're going to break it into n rectangles, any rectangles. So we're going to figure out a formula so we can plug out any rectangles that we want, all right? So when we do the lower sum, we're talking about, all right, the high end value, all right? So we're going to find a sum, and we're going to know that our area has to be below it. That's why it's called the lower sum. What we find out is the lower sum is the left endpoints that we did. So actually the graph's going to be bigger than what it was, like this. Okay, so we have to use I minus 1 for our lower sum. Well, first of all, let's break out. Let's figure out what our intervals were. In our last video, we broke up our intervals. We went from 0 to 2. Well, we said 2 minus 0, and we had to break it into 5 intervals, so we divided by 5. Well, we're breaking it into n intervals, so we're going to divide by n. So our intervals are 2 over n. All right? So if we're dealing with left endpoints, we're starting at 0. All right? If we're dealing with our lower sum, we're starting at 0. All right? Our endpoints, we're going to figure out what each of our endpoints are going to be. All right? We're starting at 0. All right? And then we're going to do our I minus 1 times our intervals. And these are all our endpoints are going to be, because when I'm dealing with my left endpoint one, so right here, would you agree my left endpoint, I plug 1 in for I get 0 plus 0, and that's 0. All right? The whole reason is this is where we're starting with our endpoints. All right? That's the whole basis of this. All right? So there's my endpoint, and let's just go ahead and simplify here. I'm going to have 2 times I minus 1 all over n. All right, so now to find the lower sum, again, we're still doing the same stuff we did. Remember, we plugged I minus 1, all right, times, well, I guess, sorry about that. I simplified that up here, all right. We plugged this into the function, so we took the function of 2I minus 1 divided by n, right? And then we took that then times our width, and our width is always going to be what our interval was, which is 2 over n. And then we did the summation, I equal to 1, and then we're going to n because we don't know what we're going to break it up into quite yet. Okay. So when we plug this into our function, so now we're going to have, what I'm doing is I'm evaluating this part in my function, all right? So what we're going to have is we're still having the summation is I equal to 1 to n, all right? And I'm going to plug 2 I minus 1 all over n into our function, which was x squared, right? And then this is n times 2 over n, all right? So what we can do here with a little simplifying, we could square all this out. On the bottom it's going to be n squared. We square each term, right? So this would be squared and this would be squared. To make life easier on ourselves, so we multiply through here, all right? This would be an n cubed. And then if I look here, I have 2 times 4, because 2 squared is 4. What we can do is I'm going to pull out 2 times 4 is 8, and I'm going to pull out an n cubed. So I'm just left over with this. Oh, sorry, I'm jumping ahead a little bit. I'm just left over with this I minus 1 squared. Okay? So what I did from here to here, I pulled out common terms, and you could expand it all out and then pull out a common term, but I was just trying to keep life simple, all right? So when you square something, you square each term. 2 squared is 4. All right, I minus 1 squared. We don't need to figure that all out yet. And then when we square the bottom term as well. So I pulled a 8 over n cubed out. And why did I do that? Because we're still dealing with a summation here. So now what I can do, and you know our summation rule, is we can pull this part out. This is just a constant. We can pull this part out. So we can have 8 over n cubed, and then we have the summation of I minus 1 squared. Now we need to FOIL the I minus 1 squared out. Okay, so we're going to have the summation still of 8 over n cubed, all right, of I squared minus 2i plus 1, right? We break this down into 8 over n cubed times the summation of I squared minus the summation of 2 times the summation of I plus the summation of 1. And these are all I equal to 1 and n, I equal to 1, I equal to 1 and n, right? And now we go back and we look at those rules that we had in that last section of our summation rules. And we look at, well, what's the formula here for I squared? What is the summation of I squared? What is the summation of I? What is the summation of 1? All right. And if we go back and if we look at those, I'm going to erase some of this stuff here because I'm running out of room. If we go back and look at those, all right, we go back and our formula says we're going to have 8 over n cubed times the summation of I squared is n times n plus 1 times 2n plus 1 all over 6, all right? And then we're minus, okay, 2 times the summation of I is n times n plus 1 all over 2. And then we are going to add the summation of 1. We're right here. Add the summation of 1. Well, the summation of any constant is the constant times our upper bound, which is n, so plus n. So there's what we have. We got rid of, and what we're trying to do, we got rid of our summation signs. And we got rid of our i's and our summation signs, and now we're just broken down into one variable, our n. N turned out to be the number of times we're going to break this thing into rectangles, right? So what you do, and I've done a little pre-work here already, and you simplify all this stuff out. And hold on here, I gotta grab my other. Okay, sorry about that. I had this written on my other sheet, the work that I did. So after, what we can do is we expand it, we multiply everything through. All right, we get common denominators, we're gonna cancel some terms out, and at the very end, all right, we'll get the next step. I got was n cubed after I expanded everything out. I got n times n plus 1, 2n plus 1 over 6. All right, so if you're watching this video, you might want to stop and figure out how that happened. All right. Oh, no, sorry. Again, I was looking at the wrong thing. Whew. Okay, I was looking at the next thing we're doing. All right, so after I simplify all this stuff out, I got 4 over 3n cubed times 2n cubed minus 3n squared plus n. And again, all I did is I FOILed stuff out, got common denominators, and then stuff canceled out. All right, so that's what I did. I got there, and when you simplify that even farther, we multiply our 4/3 n cubed in there, we will get 8/3 minus 4 over n plus 4 over 3n squared. So that's as simplified as we can get. That's our lower sum there. Now we could pick any value for n that we want and plug it in. That would break down our triangles into, or our rectangles into that many rectangles underneath that curved unit. I have one more thing to show you, and that's the upper sum, and that's coming up in the next video because this ran a little long again. We'll see you in the next